All right, so these are the notes for 3.2, dividing polynomials. I think this will be somewhat of a review for you guys, which is actually kind of the case for at least a portion of Chapter 3, and then we're building on it again, given that kind of pre-calc sort of level of thinking and looking at things. But the idea today is talking about different ways we can divide functions, working with two concepts, long division and synthetic division. Both of them definitely have their purposes for us. Today, with long division, it's mainly just to know how to do it. In synthetic, we'll again talk about how to do it, but also some of its uses. The purpose of long division, that'll be more obvious to you guys later on in the chapter when we need it, when we start talking about rational functions. So what we're going to do to start is just begin with long division. In old school long division, we're going to divide two numbers and just talk ourselves through the process, because the process for doing it with numbers is actually the same way we would do it with polynomials, with so maybe one minor way of looking at it. But for the most part, I want you guys just to flash back to like when you were in elementary school and you first got taught long division and how you set the problem up. So we'd start by getting it set up with 5 and 3/12. And then the first thing you do is start asking yourself a series of questions. So you'd say, well, 5 goes into 3, how many times? It doesn't. Okay, then you move over to the next term, 5 goes into 31, how many times? 6. Then you multiply 6 times 5, which is 30, subtract, bring your other number down, and you go again. How many times is 5 going to 12? Twice. Multiply, subtract. As an answer to the problem, like what is all that? What is your answer? Well, we usually would go with a mixed number. So we'd say we got a remainder of 2. Our answer is 62 and 2/5. Now, when we start talking about functions, we start giving these parts of the problem actually like a symbolism. So there's some names there listed out: the dividend, the divisor, the quotient, and the remainder. I think most of us obviously are clear with our remainder. We got a remainder of 2. The quotient is actually the answer without the remainder. That's your 62. The divisor is what you're dividing by. The dividend is what you're dividing into. To know the dividend and divisor maybe isn't quite as big a deal because our answers are written with quotient and remainder. But it's good to know the breakdown of those. When you look at a polynomial division idea, you get more of a symbolism where it's a function divided by a function. But if you guys look at what this says, that's actually the same thing as discussing a mixed number. For example, I can take 62 and 2/5, and I can write it as 62 plus 2/5. And that says exactly the same thing. Those are the same answer. When you guys go to do a long division with polynomials, that's how we're going to write it. So basically what you're seeing here is the equivalent of a mixed number. Now also, you guys know from working with fractions and how you write your answers that sometimes we ask you to take a mixed number and turn it into an improper fraction. If you take 62 and 2/5 and you make it improper, try to remember that the way you do that, right? It's kind of what sometimes we have different names for, but basically you take your 5, your denominator, multiply by 62 and add 2. And so what you're going to get is 312/5. But think about what you did as you took 62 and 2/5 and tried to go improper with it. You took the divisor, multiplied it by the quotient, and added the remainder. 5 times 62 plus 2, 312/5. That's actually exactly what this says right here. Take your divisor, multiply it by your quotient, and add your remainder. This is another format for writing your answer. This is the improper fraction style of writing your answer when you're dividing polynomial functions. I think it's actually probably more useful, or makes more sense to me, to write it as a mixed number. Most of the time, like quizzes, tests, and so on, we're going to probably have to do the mixed number style. But the book may ask you to do both, or one or the other. And that P of Q equals D of X times Q of X plus R of X is nothing more than a way of saying, here's how you find an improper fraction. Also, if you think about what it produces, it's sort of a way of checking your answer. If I took the divisor 5, multiplied it by the quotient 62, and I added the remainder 2, that should produce my original dividend. And that's long division done with numbers. Now, we're going to switch over to doing long division with polynomials, with functions. But we're going to do about 95% of the work the same exact way as we just did there. Okay, so we'll try a couple. I'll walk you through the first one, and then we'll have the second one kind of give you a little bit of time to sort of try it on your own. And so here's the way your problems are going to look. It's going to say divide two polynomials. Of course, in this case, we're using long division. Write your answer in both forms, so the mixed number style and the improper style. Mixed number will usually be first. That's generally how the long division is going to produce. And then you can just sort of change the format of it when you're done. The way long division starts with polynomials is actually the same way you start it with just regular numbers, the same initial setup. Now, when I'm doing long division with polynomials, I actually will ask myself the question a little bit different. So like in the numbers, you say, all right, how many times does 6 go into 31? And that's kind of the way you approach it. Here, I'll change the question a little bit. It's the same idea. Also, when you do long division, we focus on the x term, or the first term, or the term with the highest degree, I guess, however you want to look at it, with your divisor. And the way I ask myself the question is I say, what? I kind of do sort of a question mark up here. What times 2x would produce the first term in the dividend? So what times 2x is 4x to the third? Instead of saying how many times does 2x go into 4x to the third, which you could do it that way, I suppose, and it'd probably be fine too. So if I ask myself the question that way, what times 2x is 4x to the third, that's going to be 2x squared. Outside of you sort of asking yourself the question a little bit differently, the rest of the work is the same work. So now I take my 2x squared, I multiply it by the entire divisor. And then I subtract. Now, you guys know me, I like to do parentheses around any multiple term expression that I'm going to subtract, just to remind myself how the signs are working. The way this is set up, what should happen is you should get your first term to drop out. That's why you chose 2x squared. And then you just kind of keep going. So I'm going to take 6x squared minus 2x squared and get 4x squared. I'm also going to bring down my other terms. You notice I'm doing the same exact thing I would do, but just typical long division. And then just like with typical long division, I start the process over again. So now I ask myself the question, what times 2x is 4x squared? Again, I'm only working with the first term in each expression. But when I answer that question, what times 2x is 4x squared, that's going to be 2x. So now 2x times the entire divisor. And again, remember I'm doing subtraction. That's one thing you got to really watch. This would be the spot where I would see the errors for students when they're doing the subtraction. If you don't do that correctly with distribute the negative idea, and then you're making some kind of sign mistake, which changes your entire answer. But you notice again, I'm just going to do like I normally would. So these two terms would drop out. That's the point. Subtracting here, I get 6x. Bring down my other term. I've got 9. One more go round. What times 2x is 6x? And that's 3. So again, I'm going to multiply that times the entire divisor. So I get 6x plus 3, and then it's a subtraction problem. And 9 minus 3 is 6. So if you think about it, the way I went through that problem was, like I said, the only difference at all was just the way I asked myself the question. The work of it is identical to doing it with numbers, how I approached every step of the problem. Now, the thing is this problem, if it gets a little bit bigger, you get a lot of terms, a lot of calculation with signs. Easy to get lost somewhere, so you really got to be meticulous and careful about it. Now, to get to the final answer, how I'm writing my answer. So here's the mixed number version of the answer. So I've got 2x squared plus 2x plus 3 plus my remainder over my original divisor. That is a mixed number, just like saying 62 and 2/5. I mean, that's the same exact visual for what we've got there. When you go to improper, again, think about how you do it. You take your divisor, multiply it by your quotient, and add your remainder. So it'd be, for us, just another way of writing it. So this is mixed number. This is improper fraction. Okay, so what I'm going to do is have you guys kind of walk through one more. I'm going to give you some time to sort of get it set up, try to go through it, see if you can work it out, and then basically walk you through it. So what I'd like you guys to do actually is just pause the video and then try it for about a minute or 2, 3 minutes, whatever, talk to your partner, or probably watch the video, so maybe not watching it at the same time together. But anyway, just pause it, take a second to work through it, and then check your work. Okay, so hopefully you had a chance to work through it. Now we're back. We got a little bit bigger divisor and dividend both, so there's going to be more terms, which means more room for mistakes. So you really got to watch out as you go through and are you catching all the signs, doing all your subtraction correctly. Again, I ask myself the question. It's the same process we did before in that last problem. I go, what times 2x squared is 4x squared, which would be 2x squared. Multiply the 2x squared times the entire divisor. Okay, so I paused the video and erased some stuff there, and you guys are like wondering what just happened. But one thing that just occurred to me that I got to make sure I tell you guys before I go further is I was about to start going across. But look at the terms in the dividend. You're missing one of the exponents. And it would work without having it there. You just have to kind of watch how you line things up. But just strictly for alignment, so everything is like easy to keep track of, it's good to put a placeholder in that spot. And so if you're missing one of those terms, the best thing to do is just throw in a placeholder. That'll help you keep all your exponents and variables lined up nicely so as you go through you don't miss, like you don't put a squared with a cubed or something like that. So that's something I should have done right away, but okay, good that I stopped. Maybe get you guys to stop for a second and see if you thought about that when you were doing it by yourself. Did you put in a placeholder? Did it occur to you that was even supposed to be there? Now, going back to the problem again, 2x times, so as I start to fill this out. And again, the reason that's good is I'm going to kind of keep all my variables good and lined up so I don't make some simple mistakes. Now also, here's a good reason to have that set of parentheses with a subtraction because minus and minus plus, right? So I'm actually getting 2x to the third, and minus and minus, minus and plus, excuse me, but keeping track of my signs. Drop my rest of my terms down, and keep going. So what times 2x squared is 2x to the third? Well, that would be just plus x. Again, keeping track of your subtraction. Lots of signs. This is where, like I said, where the errors are going to come in. You just got to watch out for all that kind of stuff. Now, again, minus and minus plus. So I got negative 4x squared. Bring down my 1 more round. What times 2x is negative 4x squared? Well, that would be negative 2. So again, go ahead and multiply and subtract. So I got 5 minus 2, 3x, and then minus and minus plus 1. The other thing, too, to think about is, like, how do you know when you're done? Right? When is it that, when does long division stop? And basically, there's kind of two simple ways to go. Like, up top, you can't answer the question anymore. What times 2x squared is 3x? And then we're not going to be able to do that. Or, real simply is in the row of up top in your quotient, you get to a constant. You get to a number term, and then you're done. So this time I'm not going to do the improper version. I'm just going to go with the mixed number. Well, let's piece it all together. So we've got quotient plus remainder over my original divisor. Mixed number, 62 and 2/5, right? Just the same exact concept. Okay, that's all we're doing with long division. And for this particular assignment, it's just so you can do it, practice doing it. It'll have its use for us a little bit later on in the chapter. We're going to switch over to synthetic. And, why have the two divisions? Well, synthetic actually is a totally different approach. But synthetic also is limited to what you can do or what kind of divisor you can have. You can only do synthetic when you've got a divisor lead coefficient 1 and degree 1. Long division is actually universal. You can do long division with everything. So, if you love long division, which a lot of us don't want to do it if we don't have to, you could do it for anything. But given a choice for synthetic or not, I would do synthetic if I could. The comparison of the two, if you guys want to see sort of how they compare and what's the connections to it, I put a video on Schoology that you can kind of watch that. Usually I don't sidetrack during the notes because it eats up a lot of time. But you can see how they compare. But it's a different approach. So seeing what you guys remember about synthetic division, Basically, what you do is it's set up. It's kind of like a little table